Good morning, friends. Today again we will discuss on differential equation. Topic number two: first order differential equation. First order differential equation. Again, we continue with topic homogeneous equation. Okay, today we know about the differential equation, homogeneous form of differential equation, and method to solve the homogeneous differential equation. Already you know that a system is called homogeneous or a differential equation is called known as homogeneous if all the terms have the same degree. Then this is today we learn about the process how to solve this type of differential equation. And I'm sure that after this lecture you will get some clue to how to find that this equation given differential equation is homogeneous or not. Second, the how to solve the homogeneous differential equation. All the best students. Now I am continuing with differential equation of homogeneous form. And after this lecture, I have a small cue for you. You carefully listen the lecture, attend the lecture, and after this, you will be able to solve this cue. Okay, for self-assessment. Now, students, I start homogeneous differential equation. Homogeneous homogeneous differential equation. A differential equation. A differential equation is called homogeneous. A each term of differential equation have same degree. Like, for example, dy dx x square plus y square is equal to x. Like dy upon dx x cube plus x square y upon y. Here we see that the equation, first equation, it is this one. Here x to the power 2, x degree 2, y degree 2, and x, y both have 1 degree. So all terms have the degree 2. Similarly, dy dx x degree 3, y degree, x square y is this term degree 3, this term degree 2. All terms in dy upon dx have same degree. This is called homogeneous differential equation. Yes, friends? Now how do we solve this? So We take dy upon dx, like example x square plus y square. X square. So here we introduce v is equal to y is equal to vx, which also a variable. Okay, so dy upon dx is equal to x dv upon dx plus x के against differentiation, then we get, now replace in given equation. Now replace in given, so become v plus x dv upon dx x square plus v square x square upon. Okay, so all the term of x square eliminate, become v plus x dv upon dx 1 plus v square. We take x square from here common, and x square cancel, so become this. Now all we use x dv upon dx is equal to 1 plus v square upon d. This becomes 1 plus v square minus v square upon cancel. It becomes 1. So here we find v dv is equal to dx upon variable separation. Now we can easily integrate. Now we can integrate, become v square by 2 is equal to log x, and v square is become, we know y is equal to vx, so v is equal to y upon x. So this is become 1 by 2 y square upon x square log x plus, this will be, this is the answer of this homogeneous equation. I hope that again I explain a differential equation of this type. Each term have the same degree. Now we introduce y is equal to vx, dy upon dx will become, we put in this and integrate by variable separation. Okay. Now we take another example. X square by dx is equal to x square plus y square dx. Okay. This is important with respect to exam Albany University. So here we can write like this: dy upon dx is equal to x square y upon x. I can write this. Okay. Now each term have the same order. Here order 3, here order 3, here 3. So we can introduce y is equal to v, where v is also a variable. Okay, v is also function of vi and x. Okay, so dy upon dx become v plus x dv upon dx. Now replace now replace in given equation. So become this become dy v plus x dv upon dx is equal to x square x2 plus, okay, we put y is equal to px here. So this becomes v1 plus, okay, but here now we can do x dv upon dx is equal to v1 plus v cube minus x dv upon dx v minus v minus v4 upon, here this cancel, we find x dv upon dx is equal to minus v4 1 plus. Now we solve this dv upon v4 1 plus v cube is equal to minus dx upon variable separation. Okay, v and x both are the variables and we separate it. Now dv 1 upon v4 plus 1 upon, and easily integrate the equation. Okay. So this become we know result x to the power n dx is equal to x to the power n plus 1 upon integration of x to the power n. Here minus, sorry, minus 4 dv plus dv upon v is equal to minus dx upon. So this becomes v minus 4 plus 1 upon log v minus log n. V is the constant, integrating constant. Here become minus 1 by 3 v cube plus log v minus log x. So v 1 by 3, v value of v, y is equal to vx and v is equal to y upon x. Then y cube x cube plus log y upon x minus log x plus log. This is the answer. This is the answer of given differential equation. Yes, students, I explain again. This is the homogeneous differential equation because all terms have the same degree. So we introduce y is equal to vx, where v is also a variable, dy upon dx, v plus x dv upon dx. Now we replace this in given equation, v plus x dv upon dx, and this becomes x square vx upon x cube v cube upon. So with the v plus x dv upon dx is equal to v 1 plus v. Now we separate the variable and solve it. So we find dv upon dv upon v4 and 1 plus v2 is equal to minus dx upon x. And dv upon we can know integration of x to the power n dx is equal to x to the power n plus 1 upon n plus 1. So we can easily integrate the term. This is good example and I hope आप लोगों को clear हुआ होगा. Now see wonderful example, another wonderful example of homogeneous system, homogeneous differential equation of first order. This is running our differential equation of first order first degree. Now another example, x square y minus 2xy dx minus x cube okay. We see that this equation is also homogeneous equation. Why? Because we can find this term has degree 3, this term degree 3, this term degree 3. All the terms of the given differential equation is degree. So we can write like that x square y 2xy square dx is equal to x cube minus 3x square y dy is equal to. Okay. So we can write dy upon dx 2xy square upon x cube minus x. Now, now we take y is equal to Vx. Implies dy upon dx is equal to p plus x dv upon. Okay. So the given equation becomes b plus x dv upon dx is equal to x square bx minus 2x b square upon x cube minus 3x square. We put y is equal to dx in the equation. Now the equation becomes x cube, take common from each side and cancel. So the equation become in the b form, b plus x dv upon dx. B minus 2b square upon 1 minus. This is the. Okay. Now x dv upon dx, b minus 2b square 1 minus 3b. Now solve this. B minus 2b square minus b plus 1 minus 1 minus. Now this is cancel, b2b cancel. B square upon 1 minus is equal to x dv upon. dv upon dx x dv 1 minus 3b upon b square dx upon variable separation we apply here. Now dv 1 upon b square minus 3 upon divided by b square dx upon x. Now dv upon b square 3 upon b dv is equal to dx upon. Now it can easily be integrated. Now integrate the equation. So it becomes b minus 2 dv 3 upon b dv dx upon x. Here I will b minus 2 plus 1 upon minus 3 log b log. Now minus 1 upon b minus 3 log b is equal to log. Over here we can write the value of V so it become x upon y. We put y is equal v is equal to y upon x minus v log y upon x. This is the final. Okay, here we introduce CR. This is the answer of our differential equation. Okay, students. Here we complete the homogeneous differential equation of first order. Very simple step. There are only three steps. Number one, we assume v y is equal to vx. Then replace dy upon dx in the form of dv upon dx. And after this, apply variable separation method to separate the variables and integrate. Now, I hope this is very beneficial for you and you can easily understand with the video. I write some equation to for your exercise, for your practice. You can do dy upon dx is equal to x square y plus y square x upon. Similarly, second y x square plus y square plus x y square minus. Okay. Now we move at the part of exact equation and Bernoulli equation. I use here third type of differential equation, Bernoulli equation. Or we can say reduce in linear form. The difference between the linear form of the differential equation and Bernoulli equation is that a linear form equation write like this. Linear form equation we write dy upon dx plus dy is equal to q. And Bernoulli equation we can write dy is equal to qx y to power n. This is called Bernoulli equation. Okay, and how we can solve it? We can solve it by changing linear form of differential equation. For solve this type of differential equation, we do dy upon dx. Here we divide with y to power n plus py upon qx. 1 upon y to power n dy upon dx is equal to become p y we take above so p minus n plus is equal to. Now, now we assume y n plus 1 is equal to b. So minus, sorry, here minus inside this, n plus 1 y minus n plus 1 minus 1 dy upon dx become dv upon dx. So y power 1 minus n dv upon dx convert in 1 upon minus n plus 1 dv upon. So it is become 1 upon y power n dv upon dx equal to 1 upon n plus 1 dv upon. ठीक है, तो ये हम इसको रिप्लेस कर देंगे इसके अंदर, तो हमारी जो इक्वेशन है वो बन जाएगी अब 1. Now the equation become 1 dv upon dx plus pv is equal to. Now this is the form of differential linear equation. We can write this is constant term, so we can write dv upon dx plus n plus 1 pv. The equation now convert in the linear form of differential equation. Here, here we apply the method of linear equation. Here p is equal to minus n plus 1 p and qx is equal to. So here we find here a की power pb. Okay, and write down the solution. What is the solution of this type of equation? We write here the main solution b here qx plus, after this v we put v in form of y. So we get the final solution. Again I explain, this is very